is not fun? Well, I, Makwana Namreka, is here to show you that maths is just a fun challenge. It is as easy as y equals to mx plus c. And for those of you who didn't know, it is as easy as a straight line. So right now, it is the time for you to grab a paper, a pen, and a calculator and come learn maths with me.
And subtraction. So in the past videos you've seen that we've done rules of fractions. So in today's video we will be applying the rules of fraction to solve addition and subtraction of fractions. So when adding and subtracting fractions, you need to understand LCM and LCD. So LCM stands for the lowest common multiple and LCD stands for the lowest common denominator. They're basically the same thing. The difference is just that we use the term denominator when dealing with fractions. So let's read the explanation. The lowest common multiple of two or more expressions is the smallest multiple that each expression can be divided into without leaving a remainder. So basically, if you are looking for the LCM of 2, 3, and 4, the LCM will be 12. Why? Because you're going to start with the LCM of 2. You're going to say 2, 4, 6, 8, 10, 12. And then you're going to move on to the LCM of 3, which are the multiples. Then you're going to say 3, 6, 9, 12. And then you're going to move on to multiples of 4, which will be 4, 8, 12, 16. So when you check which is the common multiple amongst the 3, which is the smallest, it will be 12. So when you're looking for lowest common multiple of 3a and 3a, 6a squared, and 12a cubed, it will be 12a cubed. The lowest common multiple of variables, as I've said in the past videos, is that to find the lowest common multiple, it will be the one with the highest exponent. So let's move on to the lowest common denominator. So the lowest common denominator is the LCM of all the denominators in an expression. So here we are using the term denominator because we will be dealing with a fraction. So LCD and LCM are basically the same thing, but when we're dealing with fraction, we just call it an LCD. So yeah, in fractions, you cannot add or subtract fractions when the denominators are not the same, which is where the lowest common multiple, or rather the lowest common denominator, comes in. So let me grab my questions where we'll be working them out together. So I'm just going to be answering here on this paper, and here we'll just be calculating the LCDs. So yeah, let's start with letter A. 2 minus 1 over 2x squared plus 3 over x. As you can see here, we have an expression, so we cannot add or subtract these fractions because they don't have the same denominator. So whenever a number or a variable doesn't have a denominator and you are dealing with fraction, you just put the denominator as 1 because 1 won't affect the value of this term. So minus 1 over 2x squared plus 3 over x. So when we are looking at this, we have to find the lowest common denominator. We have to make the denominators the same, and we can make them the same by looking for the LCD. So firstly, you're going to look for the LCD of numbers. So you can see that the numbers that you have here are 1, 2, and 1, and the smallest number that you can change this numbers into is 2. So there's no need for us to say multiples of 2, multiples of 1, because we already know that the smallest number that you can reach will be 2. So we have to find a number that we can multiply with 1 that can give us 2, and a number that can multiply with the coefficient 1 of x to give us 2. So now we have found the LCD of numbers, which is 2. So the LCD of variables will be the one with the highest exponent. So it will be x to the exponent 2. Our LCD is x to the exponent 2. So we cannot say our LCD is x because there's no way we can take x to the exponent 2 to x. So let's solve the expression. So what we have to do now is change our denominators. So you have to make this denominator have 2x to the exponent 2. So our LCD is 2x to the exponent 2. All our denominators have to have 2x to the exponent 2. So how do you change 1 into 2x to the exponent 2? By multiplying it with 2x to the exponent 2. So you do not only multiply the denominator, because what happens below must also happen in the numerator. So what happens in the denominator must also happen in the numerator. So you have to multiply the numerator also with 2x to the exponent 2 over 2x to the exponent 2 minus 1 over 2x to the exponent 2. So as you can see, this denominator is already 2x to the exponent 2. So it means that we don't have to do anything to it. So let's move on to the last fraction, 3 over x. So as you can see here, we only have one x, meaning that we have to multiply with another x so that it can give us exponent 2. And we also have to multiply with 2 because we don't have the number 2 in the denominator. So it means that we have to multiply with 2x because that is only what we're shooting with. So now you're going to multiply the normal way, which is multiplying the numerators and then multiplying the denominators. So let's continue. 2 times 2, it will give us 4x squared over 2x squared minus 1 over 2x squared plus 3 times 2, it will give us 6x over 2x squared. So now as you can see, we have the same denominator, meaning that we can add or subtract our numerators. Let's move on. So you're going to keep the same denominator for all the numerators, because now the denominator is common, meaning that it gives us the permission to add or subtract the numerators. So when adding or subtracting fractions, you don't add or subtract the denominators. What you do is add or subtract the numerators. 4x squared minus 1 plus 6x. So your answer is final like this. So there's no way that you can add these terms in the numerator because they're not like terms. They do not have the same variables and the same exponents. They do not have variables with the same exponents. So basically, when adding and subtracting fractions, first step, you make the denominators the same, and then you add or subtract the numerators if they are addable or subtractable. So let's move on to letter B. Over 4a. So I chose this question so that I can show you how factorization can repeat itself in questions like this. Note that you cannot divide or cancel rather over this addition sign. You cannot say, okay, I can divide 8a squared with 4a, and then you leave this 4a out. Or you can say you cancel this and cancel this because they're the same. No, it doesn't work like that. So what you have to do here is factorize. You have to factorize. So when factorizing things like this, I remember I said you have to take out the highest common factor of numbers first. The highest common factors of numbers here, we can start. Factors of 8 are 1, 2, 4, and 8. Factors are numbers that can divide fully into a number without leaving a remainder. And then we're going to factors of 4. We have 1, 2, and 4. So we can see that the highest common factor is 4. So you're going to take it out of the bracket, and then the highest common factor of variables is the one with the least exponent. So the one with the least exponent here is a. So now in the bracket, we're going to write down the remainder after we took out 4a from each and every term, right? So after we took out 4a in 8a squared, we're left with 2a. And after we took out 4a in 4a, we're just left with 1. So basically 4a divided by 4a is 1. Close the bracket over 4a. So now you can divide, because this is over a multiplication rather. So now you can divide. You can say 4 divided by 4, it will give you 1, and then a divided by a, it will be a. 1 minus 1, and then you write down your bracket, 2a plus 1, close bracket. 1 a to the exponent 1 minus 1 is a to the exponent 0, multiplied by 2a plus 1. And then you know that we keep our 1, and then you know that anything raised to the exponent 0 is 1. And then you open your bracket, 2a plus 1. 1 multiplied by 1 is 1. 2a plus 1, close bracket. Now you're going to do distributive property. 1 multiplied by 2a is 2a. I'm really sorry for my handwriting. It is the content that matters, not my handwriting, right? And then 1 multiplied by positive 1 is positive 1. I really hope that you understand how we got this answer. So without wasting any time, let's move on to letter C. 2 over 3 plus 4 over 5. As you can see, first step, you check your denominators. Are my denominators the same? No, they are not the same, meaning that you cannot add the numerators. So firstly, to be able to add the numerators, you have to make the denominators the same. So how are you going to do that? You're going to do that by checking the lowest common multiple, which will be called the lowest common denominator. So we're going to look for multiples of 3 and multiples of 5. Multiples of 3 are 3, 6, 9, 12, 15. Multiples of 15, 5, 10, 15. So the lowest common multiple is 15. So what we have to do now is look for a number that we can multiply with 3 that can give us 15, and look for a number that can multiply with 5 that can give us 15. So when checking, a number that can multiply with 3 to give us 15 is 5. So we don't only multiply the denominator with 5, but we also multiply the numerator. And then when checking, the number that can multiply with 5 to give us 15 is 3. 2 times 5 is 10. 3 times 5 is 15. 4 times 3 is 12. 5 times 3 is 15. Now you add the numerators and keep one denominator. 10 plus 12 is 22 over 15. So this is your final answer. First step, make the denominators the same. So as you can see here, you just took 3 and multiplied it with 5, and then you took 5 and multiplied it with 3. So to avoid these long steps, you can just say, okay, if I take 3 and I multiply it with 5, it will give me the same answer as taking 5 and multiplying it with 3. So rather than doing this step, you just write down your fraction and take the denominator of the other side and multiply it with the denominator of the side, and then do the same with the other side. You just took 3 this side and you took 5 this side, because you know they will give you the same answer. So I really hope I didn't confuse you there. So let's move on to letter D. Letter D. 5 over 6 minus 4q over p plus 4p over q. So let's solve this. So as you can see, our denominators are not the same, meaning that we cannot add or subtract the numerators. So we have to first make the denominators the same. So as you can see, the LCD of numbers will be 6, because here it's just 1, here it's just 1. So the smallest multiple of each number will just end up to giving us 6, because we'll say, let me just show you, multiples of 6 will be 6, 12, 18, and then multiples of 1 will be 1, 2, 3, 4, 5, 6, the same as one of this q, the coefficient of q. So as you can see, the lowest common multiple will just give us 6. So now when checking the variables, the lowest common denominator for variable p will just be p. LCD of variables will be p, and then for q it will also be q. We don't have another variable which we can compare with to say it is the smallest exponent or the highest exponent. So now we can see that our LCD will be 6pq. So each and every denominator of each and every fraction here must have the denominator 6pq. So we have to multiply with what is shorting. So now we're going to write our first fraction. What is shorting in the denominator? What is shorting is pq. So we have to multiply with pq. We don't only multiply the denominator, we must multiply also the numerator. Minus 4q over p. So what is shorting this side is 6q. So what is shorting here is 6p. Now let's multiply. 5 multiplied by pq is 5pq over 6 multiplied by pq is 6pq minus 4q multiplied by 6q. 4 times 6 is 4, 6, 12, 18, 24. Q, you know that when we are multiplying variables of the same kind, we add the exponent. So it will be exponent 1 plus exponent 1, which will give us 2 over 6pq plus 4 times 6 is 24p squared. We add the exponent 1 and exponent 1, which give us 2 over 6pq. Now you are able to add the numerators. Why? Because you have the same. You are able to add or minus the numerators because you have the same denominator. So this is your final answer because you cannot simplify further. You cannot add or subtract the numerators as they are not like terms. So let's move on to the last question, which is E. This question I can just write it here because there is enough space for it. I really hope that you understood the previous ones and how I was explaining them. So let's do letter E now. So as you can see here, we're not having the same denominators, meaning that we have to make the denominators the same. So we can just do like this. We can just multiply this denominator 5 with 6 over 6 minus, like I've explained before, minus 2. So like this, we're just doing a short way of avoiding the long steps of wanting the multiples of 5 and the multiples of 6. So if they've required you to show the steps of multiples of 5 and multiples of 6, you shouldn't do this method, but you should look for multiples of 5 and multiples of 6. As you can see, I took the 6 denominator this side to multiply with 5, and this 5 denominator the other side to multiply with 6. I did this because I saw that if I just swap them, I multiply the same numbers together, which will lead to the same thing. So let's move on. Now we're going to say, so I choose this kind of question to show you that here you're not going to multiply 6 with 3 only. This is because this 6 is multiplying the whole fraction, the whole numerator part. So it must be multiplied like we are doing distributive property. So 2 times 6, it will be 12x plus 3. Positive 3 times 6 is positive 18 over 5 times 6 is 30 minus, then you do the same this side, 3x multiplied by 5, it will give you 15x, and then minus 2 times 5, we're starting with the signs, negative times positive is equals to negative. 2 times 5 is 10, and then we multiply the denominators. 6 times 5 is 30. So as you can see, we have the same denominators, meaning that we can simplify, meaning that we can add or subtract the numerators. So we're going to say our denominator 30, and then 2x plus 18. So this minus sign, we're not going to say it is a minus 15x. This is because this minus sign is for the whole term, is for the whole numerator. So it must stand for the whole term, for the whole bracket. So you're going to say over 30, sorry about that, 2x plus 18, negative times negative 15x is negative 15x, negative times negative 10, so negative times negative, we know it's positive, and then positive 10. So right now you can proceed by doing what? By grouping the like terms together, in which you're going to simplify. Oh, I forgot. I kept on writing 2 instead of 12. I'm really sorry about that. So let's continue. So you're going to write down your denominator and then group the like terms. The like terms, you're going to see them by them having the same variables and exponents. 12x minus 15x, and then plus 18 plus 10. So let's simplify. Over 30, 12x minus 15x is negative 3x. So you're going to minus the coefficients. 12 minus 15 is negative 3, and then you keep the variables. We keep the variable just the way they are, and then positive 18 plus 10 is positive 28. And this is your final answer. I really hope that you found this video helpful and you understood how I was explaining. If you have any questions, please do not be afraid to leave them in the comment section. Until the next one, you guys, bye.
If you enjoyed this video, please give it a thumbs up and tell me in the comment sections which topic you'd like me to cover. And remember, I do not promise to know everything, but I do promise to share and help where I can.